All right, so this video is on factoring trinomials that are in the form x squared plus bx plus c. So to factor a trinomial that's in this form, what you're trying to find are two integers that when you multiply them together, you get c, and when you add them together, you get b. All right, so that sounds kind of weird at first, but let's say it one more time. Two numbers that when you multiply those two numbers, you get c, and when you add them, you get b. So in this first one, we're looking for two numbers that multiply to make 12, and then we add them, they add up to 7. So, one second, let me get my pen set up here. Go with that. So hopefully you figured out that that's 4 and 3. So 4 times 3 equals 12, and 4 plus 3 equals 7. So once you've found the two integers, the form of the factor is going to be like this. X plus 3 times x plus 4. And that's the answer. So that's the factored form of this trinomial. So remember, if you multiply these back together, you should end up where you started. So if you wanted, you could check your answer by doing FOIL or distributed property or table or some other method to multiply these together. So if you multiply these together, you'd have x times x, that's x squared. You'd have 3x plus 4x, that's 7x. And then you'd have 3 times 4 is 12. So that's your answer. All right, so let's look at another one. Seems pretty easy so far, right? Two numbers that multiply to make 18 and add to make 9. So most of my students will start with, and so what you do, you just run this through in your head. Okay, so most people would start with 9 and 2. Okay, 9 times 2 is 18, but 9 plus 2 is not 9, it's 11. Okay, so 9 and 2 don't work. What are a couple other factors of 18? What about 6 and 3? 6 times 3 equals 18, and 6 plus 3 equals 9. So it's 6 and 3. So my factored solution is h plus 6 times h plus 3. And I could put the h plus 3 first and the h plus 6 second, it doesn't matter. That's the answer. Let's look at this one. Okay, two numbers that multiply to make 5 and add to make 6. Well, how about 5 and 1? 5 times 1 is 5, 5 plus 1 is 6. So 5 times 1 equals 5, and 5 plus 1 equals 6. So the solution is k plus 5 times k plus 1. All right, what about 20? So multiplies to 20 and adds to 9. The more you do this, the quicker you get at this. So if you're having a little trouble coming up with them, just practice it. So 5 and 4. So 5 times 4 equals 20. 5 plus 4 equals 9. So it's n plus 5 times n plus 4. All right, what about multiplies to 24, adds to 10? 6 and 4. So a plus 6 times a plus 4. And again, keep in mind, if you were to go ahead and multiply these together, you should end up back where you started. So you can always check your answer. All right, this one, a lot of times my students get tripped up by this. They're like, multiplies to 1 and adds to 2. Well, it's just 1 and 1. 1 times 1 is 1. 1 plus 1 is 2. So this one would be y plus 1 times y plus 1. And you can actually shorten that answer since these are both the same binomial, and you can write it like this. And remember, in math, we always like to write things in the shortest or simplest possible way. So really, you should simplify it to that. All right, let's see what else. Okay, here's one that's probably a little bit harder. So now we've got some negatives in here. So it multiplies to negative 30 and adds to 7. Now here's the first thing you need to notice. If it multiplies to a negative number, that means one of the numbers is positive and one of them is negative. Okay? One of them is positive and one of them is negative. And since the sum of them when you add them together is positive, that means the bigger number is going to be positive. So in my mind, I'm thinking 6 and 5. There's no way I can get a 7 out of 6 and 5 by subtracting them. Then I think 15 and 2. And there's no way I can get a 7 out of that. So what about 10 and 3? Okay, so 10 and 3 will work. So let's do this. Let's write x and 10 and x and 3. And I didn't put a plus or a minus yet. So do I want the 10 to be negative or do I want the 3 to be negative? Remember, one of them is negative because when I multiply them together, it comes out to a negative 30. Well, the answer is positive, so that means the bigger number needs to be positive. So the 10 is positive and the 3 is negative. 10 plus negative 3 is positive 7. 10 times negative 3 is negative 30. So that's your answer. All right. How about 6? Again, it's a negative, so that means one of them is positive and one of them is negative. So how about 6 and 1 or 3 and 2? All right, well, here's the problem with 3 and 2. One of them needs to be positive and one of them needs to be negative for this to be a negative. So that means that I'm going to have to subtract these. So is there any way to subtract these and end up with 5? No. So that's not going to work. What about, 6 and 1? If I subtract these, can I end up with 5? Yes, 6 minus 1 is 5. So I've got a and 6 and a and 1. The answer is positive, so that means the bigger number needs to be positive and the smaller number negative. So 6 times negative 1 is negative 6. 6 plus negative 1 is positive 5. All right, 63. This time they're both negative. So to get a negative product, that means, again, one of them's positive and one of them's negative. And when I add them together, the bigger number needs to be negative to give me a negative sum. So how about 7 and 9? So 9 minus 7 will give me 2, and 7 times 9 is 63. So I have B and 7, B and 9. I want a negative answer here, so that means the bigger number needs to be the negative one. So negative 9 plus 7 is negative 2. Negative 9 times 7 is negative 63. Again, if this is a minus, I know the two numbers have to have different signs. All right, let's look at this one. So 3 is going to be 3 and 1, because I know 3 minus 1 is 2, and 3 times 1 is 3. So I have A and 3, A and 1. I want the sum to come out negative, so that means the bigger number has to be negative and the smaller number positive. Hopefully you're starting to catch on to this. 64. Well, 8 times 8 is 64, but can't get a negative 12 out of 8 and 8. So 8 and 8 is not going to work. So this is one that's a little tougher. The factors are 16 and 4. So 16 times 4 is 64, and 16 minus 4 is 12. So I'm going to put, get my pen here, put K and 16 and K and 4. The answer the sum, answer of the sum is negative, so the bigger number needs to be negative and the smaller number positive. So negative 16 plus 4 is negative 12. Negative 16 times 4 is negative 64. And again, just real quick, remember you can always check these by doing FOIL. So if I do FOIL on this, I would get, so let me just write, this is a check, and you can always do this. It'd be k squared plus 4k minus 16k minus 64. Combine these like terms together, and you get k squared minus 12k minus 64, which is what we started with, so I know I have the right factoring. All right, 72 is another hard one. The factors are going to be 18 and 4. So 18 times 4 is 72, and 18 minus 4 is 14. So 18 and 4 are going to be my factors here. So x and 18, x and 4. They got to be different signs because this is a negative here. The sum is negative, so the bigger number needs to be negative and the smaller number positive. All right. So let's look at, I want to do all of these. That's a lot of problems. I'll skip that one. I'll skip that one. Let's look at these last four here. These are important. All right, so I'm looking for two numbers that add to be 42y squared. So look, now I have a variable here. I have a variable factor on here. And add to be 13xy. Okay, so ignore the xy here. Find two numbers that when you multiply them, you get 42y squared, and when you add them, you get 13. So what I mean by that is 7 and 6, right? 7 times 6 is 42, 7 plus 6 is 13. So what your factors are going to be is 7y and 6y, and these are both positive, so this is going to be plus. So a lot of times my students say, well, if you add 7y and 6y, you don't get 13xy, and that is true. But if I was to check this, so let me come down here and check this just to show you how this works out so that you'll be convinced that it works. So if I multiply these, I would get x squared minus 6xy plus, why did I put a minus there? It's a plus, sorry. They're both plus signs because these are both positives. That was my mistake, should have been a plus. Plus 7xy plus 42y squared. Combine the like terms, you get x squared plus 13xy plus 42y squared, which is what we started with. So this xy here will be taken care of. So when you're figuring out your factors, just worry about this. So it has to be 7y and 6y. And just make sure that the coefficients of those add to make this. So let's look at some more of these. Okay, so 9 times 5 is 45, and 9 minus 5 is 4. Okay, this has to be a 9b and a 5b, because 9b times 5b is 45b squared. So let me write this down. I have A, one of them is 9b, one of them is 5b. All right, this is a negative, so that means these have to be different signs. And the sum is a negative, so that means the bigger number is negative and the smaller one's positive. So again, I didn't worry about this AB. I figured out what multiplied together gives me 45b squared. And then I just worried about the coefficients adding up to make 4. So negative 9 plus 5, or sorry, negative 4. Okay, so same thing here. So 6 and 4 multiplied to 24. 6 minus 4 gives me 2. So I have M and 6N, M and 4N. Don't forget the N here because it's 24N squared. I didn't mention that before. The result of the sum is positive, so that means the bigger number is positive and the smaller number is negative. And I know they're different signs because of this minus sign. The product is negative. All right, so let's look at one more of those. 20y squared. So 5 and 4. Can't get 8 out of that. 10 and 2. So 10 minus 2 is 8. 10 times 2 is 20. So we've got a 10y and a 2y. One of them is positive and one of them is negative because of this minus sign. The sum comes out positive, so that means the bigger number is positive and the smaller number is negative. All right, we're almost done. I know this is pretty long. So this last one, these trinomials have a common factor that can be factored out first. The truth is you should always look at your polynomial and see if there's anything you can factor out before you start factoring the polynomial. So if I look at 4, 12, and 8, if I look at these terms, I can factor out a 4. They all have a common factor of 4. So I'm going to divide a 4 out, and that's going to give me 4 times n squared plus 3n plus 2. So all I did was divide all of those by 4. Now I'm going to do what we were doing on the other slides. I'm looking for two numbers that multiply to 2 and add to 3. So that would be 2 and 1. So I have 4 times n plus 2 times n plus 1. 2 times 1 is 2. 2 plus 1 is 3. These are both positive, so this is plus and plus. All right, on this one I can factor out 2. So factor out the 2, get x squared minus 4x minus 12. So I just divided all those by 2. Multiplies to negative 12, adds to negative 4. So 6 and 2 is 12, 6 minus 2 is 4. Okay, so 6 and 2, x and 6, x and 2. The result comes out negative when I add them. So the bigger number is negative, the smaller number is positive. All right, on this one I can factor out a 3. So I have 3 times y squared minus 5y plus 4. Two numbers that multiply to 4 and add to 5. That would be 4 and 1. So y and 4, y and 1. This is interesting. So look, the product is positive, but the sum is negative. So how do we get that? So two negatives, when you multiply them, give you a positive, and when you add them, give you a negative. So these are both minus signs here. Negative 4 times negative 1 is positive 4. Negative 4 plus negative 1 is negative 5. We haven't seen one of those yet. Let's see. I don't want to keep you here too long. So let's look at 34. We can factor out, okay, so this one we can factor out a 3, but we can also factor out an A. They all have an A. So we're going to factor out a 3A. So 3A divided by 3A is A to the second power plus 10A. So I took an A away plus 21. Those A's will cancel out. So multiplies to 21, adds to 10. That would be 7 and 3. These are both positives, so this is just going to be plus and plus. So you get A plus 7 times A plus 3. Okay. So I think that's good enough. So that was a little long. I apologize. I hope that was helpful to you. So that's factoring trinomials. So feel free to give it a like and a subscribe and leave me a comment. Until next time.